Welcome to Metabolism Matters. I'm Jennifer Woolley. Today we'll be taking a look at using indirect calorimetry to feed critically ill, morbidly obese patients. Let's take a look at a case. The case involves a female patient in her early 40s with sepsis after gastric bypass surgery for morbid obesity. The patient's nutrition parameters are as follows. Height is 5 foot 3 inches. Her actual body weight is 118 kilograms, which translates into a BMI of 46.1, and her ideal body weight is 52.3 kilograms. When this patient came in, she had a fever and she was hemodynamically unstable. And as I mentioned earlier, she had recently had a gastric bypass and had developed sepsis. To figure out her nutritional requirements, we first ran predictive equations which gave us a range of 1,237 calories to 1,518 calories per day. Now, I hesitate to use predictive equations with this septic patient for two reasons. The first reason being that predictive equations are often unreliable during severe metabolic stress. And the second reason is that the patient's metabolism is likely changing frequently, which is typical when a patient is fighting an infection. Because indirect calorimetry allows you to pinpoint real metabolism more accurately than predictive equations, this patient is a great candidate for IC. To confirm that the patient's metabolism does indeed vary day to day, take a look at the numbers we obtained using indirect calorimetry data. On day 20, the patient needed 2,351 calories per day, and on day 23, she needed 1,966 calories per day. It's kind of cool to look at where we would have been with feeding this patient with predictive equations. If ideal body weight was used, we would have underfed. If we used actual body weight numbers, we would have overfed. In a case like this, it truly is advantageous that we can measure caloric needs with indirect calorimetry. Well, that's it for today. I'm Jennifer Woolley for Metabolism Matters. See you next time.